Are we live? Let me just check. Okay, we're live on a few platforms, just checking. So on the platform that I'm using for streaming across platforms, it is still showing that we are trying to go live. So I'm checking it myself. If you're there online, please drop a comment saying that yes, you can hear me clearly, you can watch DeFi live across whichever platform you're joining from. I think we're live. Great, awesome. How are you, everyone? Good evening, good morning, good afternoon. Ola, from whichever part of the world you're joining from. I see a hi from Marco from Italy. Hi, Marco. Good to have you here. A very warm welcome to everyone who is joining, who's viewing this particular session later on. I also see comments from Somo Brata Mana. Hi there. Good to have you here. So, these are sessions where we typically invite AI leaders or data science change makers. I see a comment from Zaibi. Thanks, Zaibi, for letting me know. So, we invite data science leaders and change makers who are willing to contribute to the community and help each other in learning in their data science journeys. DeFi, if you don't know, is a global community of AI meant to educate and build AI for all. If you go on a platform, you will find resources contributed by Jayesh and a lot of other AI leaders who are coming forward to help the community learn data science for free. Everything starting from boot camps to courses to these expert live sessions are 100% free. Along with that, we work with companies and organizations, research groups primarily to help them innovate with AI. These sessions are opportunities where we get to host some really awesome change makers who are willing to teach live. So today we have Jayesh. Now, a lot of us in the data science community might know Jayesh already. For those of you who do not know, let me quickly introduce him. So Jayesh also he's a data scientist at Siemens. Professionally speaking, he's a data scientist at Siemens. Apart from that, he's a community mentor and focuses a lot of his educational work around the applications of Python and data science in the oil and gas industry. He comes from that background, and he also runs a YouTube channel called as Petroleum from Scratch, where he has uploaded a ton of tutorials, guided set of playlists and everything that you can leverage. We also have a course on DeFi, which is created by Petroleum from scratch that we are really happy to host for them and enable you to learn that. So if you want to check that out, you can go to defi.tech/courses and you can find it there. Now, let me quickly move into the session because that's what we are here for. So, in this particular session, we'll be discussing about a particular use case and talking about the end-to-end spectrum. So, we'll start off with an introduction, then go into the mathematics, do some hands-on walkthroughs, and have a Q&A session towards the end. We'll also discuss the limitations of the technique that we'll be using. So that way, you'll get a holistic perspective. Sounds good. Now, let me quickly loop in our speaker for the day, Jayesh. So, yeah, hi
Hey,
Jayesh.
hi, Mudit. Hello, all. Thank you for the introduction, Mudit. It's a great pleasure for me to that you have invited me on this platform so that I can share somewhat of my knowledge that I know with the people, right?
No, no, it's
So I guess,
sure. Yeah, thank you so much, Jayesh, for being here. Yeah, and one more thing. I mean, a lot of people might not know Jayesh comes from the DeFi community. He has been, he has explored the platform in the past and has used it. So, which makes me a
yeah,
notch happier to have him here on the session today. So,
yeah.
yeah.
During my initial days when I was learning data science, I used DeFi a lot. So yeah, connecting with you guys and having an opportunity to speak at DeFi session itself is a great opportunity for me.
Oh, the pleasure is mutual, Jayesh. So maybe I'll leave the stage to you. There's a question from, I mean, Marco that he's asking the exact name of YouTube channel. We'll put that into the text section. Probably we can dive into the session. It's Petroleum from scratch, by the way. But you will get a proper knowledge around it. Don't worry. You can also find it on the D5 website. But as we progress with the session, you will get a hint of it. So not an issue.
Yeah.
Over to you, Jayesh. We can take the session forward.
Yeah. So can I share my screen?
Yeah, sure.
Yeah. S- So my screen is visible to all, right? Once can you confirm it?
Yeah, screen is visible. Yeah.
Okay. So let's start the session then. So yeah, as Mudit said, so in today's session we will be talking about one of the application of time series analysis, or we can say time series forecasting itself in oil and gas industry. and we will be talking about crude price forecasting. Everybody knows, right? We use petrol or diesel in our cars. So that is basically drilled from a particular oil well that are present in Saudi Arabia or in India itself, in Rajasthan or Bombay High, right? So how can we use the power of artificial intelligence or the power of data science for forecasting this particular price of crude oil? Crude oil is basically the very beginning stage of the petrol or diesel with before refinement, right? So in today's session, we will be doing an hands-on coding thing on that particular thing. But before moving on to that, let's discuss some what basics of time series analysis or time series forecasting. What exactly is time series data, and how is it different from another data that we generally use in common data science problems or normal machine learning problems, right? So as the name is suggesting, time series, right? So it is automatically saying that the data that we are collecting for a time series data or time series analysis is having a dimension of time in it, right? And that particular dimension of time will affect the magnitude of your data, right? As the slide in the slide itself, it's saying that time series is a specific way of analyzing a sequence of data points that are collected over an interval of time. Some of the examples sorry, some of the examples are stock prices. We collect the data of stock prices, right, with every day. So every day the stock price is going to change, right? So that is an example of time series analysis. Another example is, let me give you an example from petroleum industry itself. Another example is oil production rate. How much oil is I am producing in a particular day, right? That is again having a time dimension that okay, on 25th May, I produced 600 liter of oils, and on 27th May, I produced 800 liter of oils, right? And in these particular type of data, in these particular time series data, there will be a link of this time also, that with increasing time, if you think it on the prospects of physics, right? We started sorry, we started to produce oil from a well, right? So with over time, the oil production is going to reduce, right? Because we are producing from a long time, so the pressure inside the well has automatically decreased, right? So the oil production is going to reduce. So the time is playing a factor. So automatically time is playing a factor, right? For example, in 6 months, my oil production rate reduced to half, and in coming 3 months more, my oil production reduced to the 10% of the initial value, right? So time is having a factor there. So you can say in this way also that time is a crucial variable in time series data, because it shows how the data adjusts over the course of your time points or over your data points, right? And also it provides an additional source of information about the time itself and the dependency between the data itself. And how this time series data is different from other data, other normal tabular data, is basically because it has this particular time dimension, and analysis can show that the variables or the points that are present inside the time series data changes over time. And again, some of the examples are your weather data, right? If you guys have seen the news, there are these weather forecasting. So that is basically a time series data, right? They have a lot of historical data from past years, and using that data and applying some of the algorithm or sorry, some of the models, they are trying to forecast that okay, what will be weather or what will be the temperature in coming next 3 4 days, or is it going to rain or not. Other example is your heart rate monitoring, right? If we do the heart rate monitoring in EKG, that is also your time series data itself. Stock prices already is an example. Some of the industry forecasts, or and one more example from industry or manufacturing industry, you can say, is your predictive maintenance. Predictive maintenance basically means when is your instrument going to fail. This instrument can be anything. It can be your air turbine for from a windmill, right? Or it can be your compressor. So if we have historical data of that particular instrument, and we know that in history after these points, or when some of the parameters reached, for example, let's take example of compressor. We have some of the parameters of this particular compressor. We have pressure operating thing, temperature operating thing. What is the temperature when we are operating a compressor, right, over a period of time. And we know that when the pressure or temperature is reaching a certain limit, then after reaching that particular limit in n number of days, my compressor is going to fail, right? So this is also an example of time series forecasting, or you can say application of time series forecasting. So in this particular way, we can utilize this particular time series data itself. Now, coming to the next point, some simple forecasting methods. So before moving on to the LSTM, long short term memory, that we are going to discuss in today's session, we will be discussing some simple forecasting methods and why our LSTM or RNNs are better than these simple methods. So one of the most simplest method in forecasting time series data is average method. So in this average method, we do nothing. We just take the average of the last historical data, and we will say that okay, this particular average will be forecast for my future values, right? So if I give you an example here, let me start my pointer. So again, let's take an example of temperature forecasting itself. Temperature. So I have temperature for last 3 days, right? Let's assume it's 30 degrees Celsius, 28 degrees Celsius, and 25 degrees Celsius. So if I'm going to use this average method, so the temperature for my next coming days, tomorrow or day after tomorrow, will be nothing but the average of these three values: 30 plus 28 plus 25 divided by 3. So in average method, we just directly take this average of the past values and say that okay, this is going to be my future value itself. The next one is naive method. In naive method, what we do, we take the last value from our past historical data, and we say that okay, this particular data is going to repeat. So again, in this particular temperature example, if I use naive method here, so my temperature is going to be 25 degree itself, because it is my last point, right? So again, for the next day also, it will be 25 degree. So these are quite simpler methods, right? And generally time series data or any data doesn't changes like this, right? That's why we kind of generally not use these simple forecasting methods itself. And one of the, one of the modified method of name method itself is drift method. So in drift method, along with the last point, we kind of add or subtract a particular variable from the last value, and this particular variable changes with time, and this particular thing is known as drift. So for example, if I take this 25 degree again temperature example itself, so if I'm going to use drift method here, let's say drift method here, so I am going to take 25 degree, and I'm going to add or subtract a certain variable depending on some of the historical data itself. For example, I am predicting tomorrow's temperature, so this plus minus variable, let's say it is x, or let me write it here, 25 plus minus x. So this x can be dependent on the temperature of last year for the same day. Let's assume that tomorrow is 2nd October, right? So there can be scenario that okay, on the last 22nd October 2021, the temperature was around 20 degrees Celsius. So depending on this particular value, this x value changes, right? So these are three some of the three most simplest method that are used for forecasting. Now coming to the ARIMA model. These ARIMA models are statistical type of models, just like your shallow learning techniques that are your linear regression, logistic regression, and all those things. But these ARIMA models are your statistical models in time series data, right? And this ARIMA kind of stands for it is made of three different models. One is your AR model, or AR model auto regression. AR stands for auto regression. So basically, AR says that we are going to forecast the variable of interest using a linear combination of past values of variable, right? That's why auto regression is there. Auto is saying that we are regressing our, for example, again, let's take the temperature example itself. I have temperature of last 5 days: 20, 21, 23, 24, and 25, right? It is my T1, T2, T3, T4, and T5. So AR auto regression says that my T6 will be equal to a linear computation of past values. So it will be W1 T1 plus W2 T2, in this way W5 T5, and these weights are calculated in our training process in auto regression. So it is kind of a linear regression itself, but with the with the target, but the only difference is here the target variable and my feature variable is same, that is my temperature, right? So AR auto regression is clear to all, right? The next model that is used in ARIMA model itself is MA, that is moving average. So in moving average, rather than using the past value of my forecast variable in regression, a moving average model uses past forecast errors in a regression like models. So here my scenario will be T6 will be equal to my T5 plus the error term that I have got 5. Not here, error will not come here. 5 will be coming here. 5 will be your term depending again on historical data. Now your T7 will be equal to your T6 plus 5 error 1. Now this error 1 will be equal to, this particular error 1 will be equal to T6 that we have forecasted. Let's assume it is T6 hat minus T6, that will be the actual temperature for the sixth day. So in moving average, we are just taking the average of past errors in a regression like models. Auto regression, we take the linear combination of past values. Moving average, we take the combination of the past errors, past forecast errors. And I stands for integration. So sometimes what happens, these ARIMA models basically have sorry, one condition, that the data that we are using here need to be stationary. Data need to be stationary. Stationarity basically means its mean is not changing over the time and its standard deviation is not changing with the time, right? And also there can be there are two more concepts known as seasonality and trend. Seasonality and trend. So basically, as the name is itself suggesting, seasonality is for let's take this again, temperature data. There can be a chance, right? This is my temperature data. Let's say this is my temperature data. My y-axis is denoting temperature, right? And let's take it like this way. And this is my time. So this particular thing is for, let's say, 2015. This is for 2016. And in this way, time is increasing, right? So if you see this particular plot, you can say that in summer, our temperature will be increasing, right? Let's say this is particular points represents summer, so my temperature is increasing. So there is a seasonality in the trend, seasonality in the data, right? That whenever summer is approaching, my temperature start to increase, and whenever winter is approaching, my temperature starts to decrease. So with time there is some seasonality, right? With seasons, my data is kind of showing the same behavior. So this particular thing is known as seasonality. And trend is trend is basically, if you see, due to global warming, our average temperature is increasing itself, right? So if you see this particular plot itself, our temperature is kind of having a upward trend, right? So trend is basically denoting that on a larger scale whether my data is increasing or decreasing, right? Now if this particular thing, trend, is present inside your data is not stationary at all, because your mean will be changing and standard deviation will be changing, right? So in that scenario, we cannot use ARIMA models or these models directly. So for solving that particular thing, this I integration comes into picture. So integration, basically what this particular things for, again, if I take example of some temperature data, this is my temperature data, and after running some of the statistical or hypothesis test for time series analysis, I get to know that this time series data is not stationary. This is not stationary, right? So I cannot use ARIMA model directly. But what after this particular thing, what I did, I just subtracted my TN with the last time step. So basically, if I write it here again in clear thing, this was my data 2021, 25, and so on. And this data was not stationary. Okay, this data was not stationary. So I differentiated it by 1 degree, right? Let's say t dash. So that will be my 25 minus 21. Here this point will be my 4, and 21 minus 20, it will be 1, it will be empty. In this way I got this t dash. And again, if I run the statistical test on this particular t dash data, I get to know that okay, now my time series has become stationary, right? So now I can use this t dash directly in my ARIMA model for training. So this 1 degree of differencing is known as differencing itself. But at the last point, when we are going to forecast our data points, we need to add these values again, right? So the opposite of differencing is integration, right? So that particular thing is represented by this I, integration. So RIMA is a kind of you can say combination of these three different models running together for giving a result. And it is highly used statistical models. But in the coming times, with the sorry, with the advancement in the technology, or with the advancement in the computing power, our neural networks has came into picture. And also, as the data is also increasing in very high quality, in a very high quantity, so our neural network comes into picture. And again, in time series data itself, when we have a high frequency time series data, that may have a complicated seasonal patterns. Their seasonal patterns, so maybe there can be a chance that that eye component is not able to catch that seasonality in that particular time series data, right? So RIMA will not be able to deal with this. So for dealing with these type of data problems, our RNNs or LSTMs comes into picture. Again, now there are further more advancements in RNNs and LSTMs. There now you can also use transformers and attention based techniques. All those things you can also use. But yeah, we will be talking about RNN and LSTM itself. So RNN and LSTM comes into a picture, right? So your RNN is basically a neural is a neural network type of thing that have a sense of memory also. Your your simple ANN doesn't have sense of memory. You just feed the simple data in that will be able to he will be able to learn some relationship between X and Y, but it will not have that time dimension in it, right? That the time dimension that we talked about in the beginning. So for solving that particular thing, the RNN comes into picture that have a sense of memory, which helps it in keeping the track of what happened earlier in sequential data, right? Or earlier in time series data. Sequential data basically generally comprises of your natural language data or your time series data. Thus, it also helps in gaining the context and identifying the correlation and patterns from past itself. For example, let's take an example how RNN is similar to our brain itself. As we human, as we don't start thinking from scratch every second, right? We kind of have some memories of our past or our childhood, right? So that particular thing is enabled in RNN itself. ANN doesn't work like that. ANN doesn't have memory in term of time, but RNN have the memory in term of time, right? And here this particular thing comes the our structure of RNN. So basically, if you remember in ANN, let me draw a structure of ANN also. In ANN, what happens? This is our X, right? We just feed our X data, our features in the ANN. Let's just draw it, and we just get an output. Let's write one more ANN here, Y, right? So these simple ANNs are feed forward networks. We are just feeding the data in forward direction itself. Back propagation is there, but that is for weight updation. Our data is flowing through in from left to right direction in forward direction, right? In RNN, what happens? RNN, we are also feeding the data back to the cell itself. We are also feeding the output back to cell itself. so that it can learn that temporal relationship within the data itself, right? So here, if you see, this is our simplest structure of RNN. If you see, when I am unfolding this RNN, and let's assume that we have only we have three steps, three time steps, right? So our here, if I assume, where is my cursor? I have temperature for 3 days, 20, 21, and 22, right? And by using these temperature points, I also, let's assume that I also have data for rainfall in mm. Let's say 5 mm, 7 mm, and 10 mm. So my problem statement is, by using the this temperature thing, I have to forecast my rainfall in next day. So what will happen in RNN? Our 20 degree, that is, this is our X, right? So our 20 degree Celsius will go inside this neuron, and there will be some computation depending on your activation function, uh, and it will be mapping your this 20 degree Celsius with 5 mm, right? 20 with 5, right? And some of the hidden state will be coming from this neuron itself, and this hidden state is again transformed for the next time point, that is my 21 degree Celsius, and this 21 degree Celsius is mapping with 7, and this 22 is mapping with 10. So this particular thing, the hidden state, is also coming from a previous cell, that is kind of having a relationship between X and Y for the previous time step, right? In this way, the previous time step relationship we are kind of forwarding in the next time steps in RNN. That's why there is this loop that we are seeing here, right? So this is simple RNN. Basically, it tries to remember all the things from the past theoretically. But when it comes to the practical, when we have a large gap between our X and Y, for example, I want to use the data from 100 days back, temperature data from 100 days back. Let's assume the data was 35 degrees Celsius, and I want to use this particular temperature data for forecasting today's rainfall, and it has a gap of 100 days, right? So in this scenario, RNN are unable to connect the information, right? You can say that RNN is kind of have a small memory. It doesn't remember from a large past. So for solving this particular thing, LSTM comes into picture, and the name of LSTM itself is long short-term memory. So it has a long short-term memory. So basically, it is kind of an upgradation of RNN itself. Again, the recurrent things are there, but apart from that, the two new things that comes into picture is cell state and hidden state. In here, RNN itself, if you remember from this particular thing, only hidden state was present, right? So hidden state was taking information from the last time step and giving it to the current time step, right? So in addition to this hidden state, one more state cell that is known as cell state is present inside your LSTM, and this cell state is basically the aggregate memory of LSTM network over all the time steps from history, right? So basically, this cell state, the above conveyor belt, if you see here, this cell state is having all the memories from the past, from the starting of the data. In hidden state, that thing was not present. Hidden state is basically, you can say, encoding of the encoding of a characterization from the previous steps data only, previous step data only. On the other hand, your cell state is meant to encode all the data from previous time steps, all the previous time steps. So in this way, in the cell state, all the previous memories will be will be saved, but your hidden state is more of concerned with the most recent time step. That's why RNN was able to uh, get the information for the small gaps, but when coming to the large gaps between X and Y, a large time gap, in that scenario RNN were not successful. For that scenarios, LSTM came into picture because of the advantage of this cell state, that is having all the memories from the previous your previous data points, right? And your hidden state is kind of not equal to the output or prediction. It is merely, you can say, an encoding of the most recent type step. And the complete structure of RNN looks like this. It has three gates in it. One is forget gate that we are going to discuss here itself. This is your forget gate, this is your input gate, and this is your output gate. So forget gate is responsible for deciding which of the information is useful and from the past data, and which we need to forget, right? As the name is suggesting itself, forget gate. Your input gate will decide which of the information from the current data point or from the current time point we are going to take, and which of them we are going to neglect. As, again, the name and input gate is suggesting, and output gate will decide what we are going to give output in the next state itself, right? So let's start with the our first step in our LSTM, that is our forget gate, that decides what information we are going to throw away from the cell state. So this particular thing that you are seeing here is my forget gate, and let me go here. This is my input point for current data point, for current data step, that is my T, right? And this is my hidden state coming from the last time step, T minus 1, hidden state coming from T minus 1, and this is my cell state coming from T minus 1, right? So hidden state entered at this point at the forget gate, and after that the matrix of hidden state and current your current data from time T, here you can see this is the matrix. This matrix is multiplied with the weights of this particular point, that is our WF, and the bias is added just like a uh, simple your ANN operation, where we generally multiply WX plus B, and then activation function is applied, right? So in the forget layer or in the forget gate, our activation function is sigmoid, and this sigmoid decide how much of the data I need to take from my past or historical data as T minus 1 from the past time step data, right? If the our value of sigma value of for this particular thing complete function is coming 0, then I'm going to take any data from the historical point, right? And if it is coming 1, then I'm taking the complete ht minus 1 for my updation of cell state, right? So basically in first step in forget gate, we are deciding what we are going to take from the uh, previous hidden state, right? And as the sigmoid is present, so there will be a number between 0 and 1 for each number in the cell state ct minus 1, right? And 1 represent that we completely keep the data from the last state, and 0 represent we completely get rid of this, right? So this ft will be equal to 0 and 1, will be having a range of 0 to 1, right? And this ft will be multiplied at this particular point with the previous ct minus 1. The complete flow we will be see in our upcoming slide, but forget get, just remember that forget get decide what information we are going to throw away from our cell state from the previous time step, right? Now the next steps that comes into picture is to decide what new information we are going to store in the cell state, right? So here again you can see we are having our hidden state from a previous time step. We are having the current xt point, right? So our first step here, this input gate basically have two steps. Our first step will be having a sigmoid layer that decide which values we will update. This sigmoid layer here you again can see, and the output from this sigmoid layer will be it. So we are just taking the sigmoid again with the wi weights of input layer, bias of input layer, and our hidden state from the past cell, and our xt from current data sets, right? From current time point. So this it will be calculated. This is my first step in the input gate, and after that a 10h layer, here you can see a 10h layer is applied that will create a vector of new candidate known as ct dash. So this is my new candidate for cell state ct dash, and that again will be equal to 10h and weight multiplication of weights and data plus bc, right? Now these multiplication of this it and ct will take place. Just remember at this particular point, if you see the cross sign, so multiplication of it is ct is having at this particular point, and this particular information will be added in my cell state data or cell state that is coming from here from the previous cell itself. Again, just remember this particular thing. In the last, again, we are going to discuss the complete flow. Now it's now time to update the old cell state into the new cell state. So as we said, ft we calculated, right? ft we calculated by just taking the sigmoid of your ht minus 1 and xt, right? it again we calculated in our input gate. Again, it was a sigmoid function, and ct, our new candidate, was there with the 10h activation, right? So now we have all these three values. So now the new cell state will be equal to the previous this previous the output from the forget gate that was in between 0 to 1 will be multiplied with my previous cell state, right? So it is in between 0 to 1, so it will automatically decide how much of the data or how much of the information I want to retain from my previous cell state, right? 0 means no information from my previous cell state, 1 means complete information. And that and after that, so this is the, you can say, effect of my forget gate, and this is my effect of input gate. So multiplication of this it and ct will decide how much new information I want to add in my cell state for current time point, right? So this particular addition is added here. So data from the past, data from the current time step, and addition of these both will give me the cell state for current cell, right? And again, now this cell state will go in the next cell. In this way your what you can say calculation goes on. So this basically this ct will remember all the historical data, and ht that we haven't calculated yet, ht we need to calculate, one more step is pending here in the calculation of ht. This will decode the data from the current cell state itself. Now comes our output gate, or the gate that is providing us the ht, or that is providing me the output information. Finally, we need to decide what we are going to give output, right? So this output will be based on cell state itself. So here you can see, here it was ct minus 1. Till this point it has become ct because we have done the multiplication and addition itself. Now in this ct again, we will have a 10h operation of this particular ct, and multiply that with this output gate, or you can say ot thing. This ot will be again your one of the sigmoid function of your historical cell state and current data point xt, right? This will be a sigmoid function of your historical cell state and current data point, and that particular ot will be multiplied with the 10h of your current cell state. So basically your current hidden state is getting information from cell state itself, right? And this cell state is having information, or you can say information from all the past data, right? So in this way the data travels inside your LSTM, having all the information from historical data itself. And this ht is basically your encoded information for current cell. Again, this is decoded when we are taking the output in our final cell for some forecasting thing or whatever thing that we are doing, completely dependent on our application. So in this way your complete LSTM works. Now we will be going to our coding part. So if you have any doubt, you can let me see the chat itself. Okay, or maybe we can take the doubts in the Q&A session later. So now coming to the hands-on part, or how we can apply this LSTM thing. We have discussed a lot that okay, LSTM can do this and that. How LSTM can be applied. So first of all, before moving to the that particular thing, let's first talk about how LSTM takes data. Right? For our scenario itself, we have crude price data, right? We have crude price data, and I'm just assuming that we are having, just assuming that we are having 1,000 days of crude price data, right? Now I have to forecast my crude price by using LSTM. This is my LSTM model. So how I have to prepare this particular data so that it can be fed to this LSTM model. So first of all, the first thing that comes into picture is LSTM takes data in the form of tensor, right? In a three-dimensional tensor, it will take data. So I have to transfer this. You can say that 1,000 points are there, right? So the shape of this particular thing will be 1,000 cross 1, right? Sorry. So I have to transfer this particular 1,000 cross 1 into a three-dimensional tensor, right? And the shape of this three-dimensional tensor kind of look like this. Let me tell me what each thing represents here. So we have to kind of make batches out of this 1,000 data points. So what will be the approach? I'm saying that, okay, some 50 days of data is affecting my 51st day of crude oil forecast. So let's assume that this is my T1 and this is my T50 and this is my T51. And I am saying that past 50 days of historical data of crude is affecting my 51st day of, you can say, crude price, right? So I need to map this T1 to T50, T1 to T50. I will map with T51, right? And now T2 to T51. I'm talking about the training process currently. Now this T2 to T51 will have some mapping condition with T52, right? So this particular mapping condition I need to find out. So by using that mapping function, I can directly forecast in future afterward, because for the last 50 days for 950, 2000, if I take the data for these last 50 days and I know this function fx by using the historical data, that what it was my mapping function between t1 to t50 or tn to tn plus 50, I can use that function fx here and just pass these x values, and I will be able to know the price of crude at t 1001 first day, right? So in this way I need to make my data. Okay, so if you see here, my x will be let me come here. So my x in this scenario will be t n minus 50 to tn, these 50 data points, right? And my y will be tn plus 1. In this way, I have to create batches, right? So how these batches will be created? So first 50 data points, if I see here, first 50 data points, T1 to T50, this is my first batch, right? The second batch will be my T2 to T51, and third batch will be starting from T3 to T52. In this way, these batches will be formed, and this new dimension is added, the third dimension that I was talking about, right? So in this direction, in x direction, my number of points are just one, because we are doing univariate analysis only. Our price is variable as well as target itself. So our number of points in this x dimension is 1. My y direction again depends on your domain knowledge, or on your you can say depends on your application that you are solving, and applying, you need to apply some of the domain knowledge for that particular application. For example, here I just assume that, okay, my 51st day data is kind of dependent on last 50 days data, right? So my number of points in y direction or y dimension is 50, and this third dimension will automatically be calculated, because we are taking t1 to t50, t2 to t51, and our last point will be t951 to t1000. So it will be around 950 batches in my z direction. So these 3D array with again your y1, y2, y3 here, our y will be for this particular thing will be t51, this particular thing will be t52, t53, and here, okay, here 1000 will not come, here 999 will come, and here 950 will come because we don't have the data for T1001, right? So our Y for this particular thing will be T1000, and all this X and Y we will feed to our LSTM model, and that will give me output of function fx, that is basically estimating my Y by taking this X as input. So in this way we feed our data in an LSTM. Now let's go to the code. So first of all, I will be importing some of the basic libraries, pandas, numpy, and matplotlib, right? And after that, I'm getting the data of crude price from this particular website. If you see this particular website here, so here you can see it has a complete data of your crude oil from 1987, I guess. So I'm reading this particular table in Python by using pandas. So I'm using pandas read HTML function and reading the table from that particular website. So now when we use this read HTML function and read the data frames or read tables from a particular website, that is stored inside a list. So if we see this df will be a list. Let me show you this df. So that data frame will be stored as an element inside a list, right? So first of all, I need to get that data frame out of list. So the first element inside this df list is my data frame itself. So I'm just indexing the first element. And now if you see df here, our data frame has been extracted out of list. This is my data frame showing the series name, that okay, we are talking about Europe Brent spot price. Period is kind of, code screen is not clear. Okay, let me zoom it a little bit. Now is it clear? Somabrata. Right. So this is my data frame. Period is kind of representing the time for which date. If you can see 26th, it has data for 26th till 26th September. My oil price was around $82, and starting from 20th May 1987. Right. The add we just saw. So first of all, I will be extracting the period and values only. This crude price values only, because I'm going to use these two only, right? So I've just extracted these two columns only here, right? Now I will be converting this period into a date time format. Currently it is kind of, you can say, a number itself. So first of all, we will be converting it into a date time format, so that visualization will be easy at the later stage. So I'm using pd.to date time function at this particular thing. I have passed the format in which format I want my this particular datetime thing. Now, if you see my df, I have extracted, or I have converted this period into a datetime format here. Right now, this period column is not longer needed, so I'm just dropping it out, and I'm setting this date as an index for a while. Right, and if you see, it is kind of starting from 2 days and going till the 20th May of 1987. So I'm reversing it so that our data frame look like it's starting from the past values and coming to the 2 days or present values, right? So I just reversed it, starting from 25 1987 coming to 26 9 2022. Now first of all, let's visualize the data, right? So in this way, my crude oil price is changing from past, you can say, how much year, 30 years something, right? Now I'm going to use the complete data for forecasting purpose, right? So first of all, I will be getting the data values itself, right? I'm just extracting the data values and storing it in a df. Now before moving on further, I will be scaling the data. So what I have done at this point, I am scaling complete data. I'm not just separating training or testing data at this point, but that thing you can also do. But for the simplicity purpose, I will just pass the complete data frame, the complete data value itself, and I'm using standard scaler at this point, right? So I've scaled the data now. I have 8988 points, right? And my scaled data kind of look like this. If you see, it has been scaled by using standard scaler itself, normalized the data, right? Now I need to decide that time, that particular time window that I was talking here, right? The 50 days that I was talking, that okay, let's assume that 50 days are affecting 51 days data. So I'm just taking 100 days for a random guess or assumption that okay, 100 days of past data will be affecting by 101 day. So now the things are clear, right? That from xt to xt plus 100 will be used, and to map it with the xt t plus 101 at 101th step, right? So I will be creating my data in that way only. But first of all, let us separate the training data and testing data. So as the data points are used, I am using around 96% of to complete data as my training set, and last 4% for my validation set or testing set, right? So these are points for my training data and testing data. Now if I see my training data here, this is my training data, right? Now in this function I am doing that particular thing, creating the data set in this batch format itself. So if you see what it is doing, it is taking the data set as an input, and it is taking time step as input. By default I have set it 1, but as we have set the time step 100, so I will be giving that 100 as input here, if you see. So after that, what we are doing, we are just making two lists, x for x and y, right? And my x values for I in range of length of data set minus time step, right? So when my I is 0 for my first iteration, let me get my this one itself. So let's assume when my I is 0, right? So when my I is 0, so this particular thing will be 0, and this will be 100 because we have set 100, right? So A will be having my crude price values. Crude price values, let's denote that x0 till x100, right? This is my A for my first iteration of for loop, right? And that A will be appended inside your x data x, right? We are storing these 100 points in x, and my data y, again my y I is 0, 100, right? Let's say this was till 99, not 100. It will go till 99, 100 points, right? Because our indexing starts from 0, and the last step is not taken, right? So x0 to x99 goes inside my x yeah, data x, and my y is appending my point at x100, means my 101st day data. In Python, our indexes starts from 0, right? So x100 is denoting my 101st day data, right? So that is appended inside my y. This particular thing is appended inside my y. Now my 0 is 1. So in that scenario, our a will become x1 to x100, and this will be appended inside my x, and my y will be my x101, and that will be appended inside my y. So in this way I will be able to make the batch. I will be able to make the batch, right? And let's see that particular batching thing here. So this function is kind of used for making the batch. By default in TensorFlow, there is I guess the name of the function is data time data manufacturing or something like that. In by default there is some function present in TensorFlow also that you can also use. But yeah, I have made this function itself that I'm going to use, right? Now I'm just taking or you can say creating the data set by using this create data set x train y train x data x test and y test, and my time step is w, that is equal to 100. Now if you see the shape of my x train and y, x train and x test is 8628 into 100. 8628 is kind of representing your this third dimension. 100 is representing your this particular dimension, and currently it is in two-dimensional array. I have to convert it into a three-dimensional by just saying that okay, the point that is present inside this two-dimensional array is x itself. So just by using np dot reshape, I'm going to reshape it in the next step itself. If you see, I've just added the third dimension as one itself, right? Now if you see x train, this is your three-dimensional array, right? This is your one batch of 100 data points. This is your second batch of 100 data points. So our x data is ready, or y data was already ready, right? now just form our LSTM architecture or LSTM cell. So I'm just importing a dense layer and LSTM layers from TensorFlow, Kera layers, and sequential models we are going to use. I just made a small model here. I just use 50-50 neurons because I don't have a GPU support, and it will take a lot of time if I kind of extend the size. So for starting purpose only, I've just taken 50-50 neurons only. You can change these neurons or the layers itself at later stage. So I've just used LSTM layers, and at the final layer, I'm adding a dense layer that will be giving my output, right? That will be giving my Y, or that will you can say that is giving my forecasted value here, right? Loss I'm using mean squared error. Optimizer I'm going to use Adam itself. So our model is kind of looking like this, having total 50,851 parameters. Now I'm just fitting my model on X train and Y train. Validation data will be X test and Y test, and I'm just running 10 epochs so that it will take less time, right? So the main thing that need to be remembered is that in an LSTM cell, and let me stop this. Let's run for one epoch only for the timing purpose. In LSTM cell, your data goes in three-dimensional tensors. So the main thing that comes into picture is to convert your data into that three-dimensional tensor. Again, the dimension will be in such a way that number here will be your X features. In our scenario, as it is univariate only, so only one feature is present, but there can be a scenario that there are a number of variables and by using those and number of variables, we have to forecast some Y, right? So in that scenario, your dimension or shape of dimension changes in this direction. Your Y direction is kind of decided by your domain knowledge, and Z direction will automatically be created with the depending on your this Y direction itself, right? So I've just trained for one epoch. I just run this particular model for one epoch, right? Just using this model for predicting X train and X text. Right, I got train predict and train test predict from my model. Now I have to inverse transform that particular thing by using the scalar that we have used for scaling our data, right? And if now in this step I'm just calculating the mean square root error, that we obviously will come high value because we have just trained for one epoch and our LSTM model is also small, right? So this particular thing are my errors, right? And then in this next few steps, I'm just making the data frame for my predicted values and my actual values. I'm doing nothing, I'm just making a data frame itself. So it is basically simple Python code itself. So if you see my final data frame, so it is having, these are my initial actual values and these are my predicted values, and first 100 values will be nan, right? Because first 100 values we have taken for predicting the 101th value, so those 100 values are not predicted, right? So first 100 values will remain nan itself. Now I'm just in this particular cell, I'm just plotting my actual values and my predicted values for training set and testing set. Remember, guys, at till this point, we haven't done any forecasting yet, right? And I guess in one epoch itself, my model has overfitted looking on the curves. Or maybe there can be a scenario that scale is large, that's why it's looking. So this is result from for my training set, and this is for my testing set. Okay, now I can say that okay, from testing my model is kind of a little bit good. Now I need to use this model for forecasting purpose, right? Because till this point we already had the data, we are just seeing that how good my model is predicting for the data that we have, but how to forecast in the future, right? So what does that particular thing mean basically? If you I see DF, we have the data till 26/9/2022, right? Now I want the forecasted value after 26th, right? So first of all, what I'm going to do, I'm making the data frame, or taking the data frame out of it. First 100 values I'm just rejecting because the predicted price were nan. So I'm just representing it as DDF, and from this DDF I'm going to use this predicted price. But first of all, let's see our test data shape, right? It was 360. If you remember, the last 360 points were my testing data, right? So now what I'm going to do, I will be using the last 100 points and we'll be predicting the output for 27th of September 2022, right? So here, this thing you can see for the next 1 day price. I'm just taking last 100 days data from the test data, right? So test data minus 100 and just reshaping it into 1 cross 1 array, right? So this will be my X input, last 100 days data. Now by using this 100 days data, I will be able to calculate the last 100 days data. I will be able to calculate the crude price for tomorrow, right? But what for the next steps? What if I want the crude price for next 30 days, right? That thing we are going to see now. So first of all, I'm just converting this X input into a list here. It is. So this is my list of last 100 days data, right? Of crude price scale, standard scale raised, right? Now, for forecasting in n days, or for our example, we are taking just 30 days. For forecasting in 30 days, what logic I am going to use, that is written here. Let me tell you step by step at this particular point. Mm, Just give me this. Okay. So what will happen? This LST output is going to be your output for next 30 days, or forecast for your next 30 days. And step, the time window that we are using 100, right? This is that particular thing only. I'm initializing I equal to 0, and while I'm running a while loop. So they basically, this while loop will be run for 30 days forecast while I is less than 30. What is going to happen? So there is one if condition and one else condition. If condition is saying when my length of temporary input is greater than 100, temporary input is your this thing. Currently it is having only last 100 values, right? Last 100 days value, right? So for the first iteration of while loop, my if loop is not going to run, my else loop is going to run, because my length of temporary input is equal to 100, not greater than 100. Now what is happening in this else loop? If you see, let me see, for the first iteration, your else loop will run. So it is just taking that X input that we have formed above 100 days array, right? 100 days, last 100 days arrays, and we are just converting it into a three-dimensional array again, because our model will take a three-dimensional array, right? So the shape of that will be equal to 1 into 100 into 1, nothing else. 1 into 100 into 1. So I just have one batch of 100 days data, and dimension is also 1, because we just have crude price, right? So I will reshape that array into this 100, 1 cross 100 cross 1, and I am putting that X input inside my model.predict function, right? So this predict will work, and it will give me the this y hat will be my uh, crude price for 101 day, right? Or you can say the next day, or you can say for the tomorrow. So this is my 101th day crude price, right? Now, this 101th day crude price, I am again going to input it inside my T input that was having last 100 days data. That was having 1 to 100, right? I'm just, if you see here, I'm just extending this particular list and adding 101th day data, right? Here in this list itself. Now, my next step will be from this T input, I'm going to take the last 100 days data starting from 2 till 101, and again use this particular data for predicting 102. Again, I will input it in the list itself. This time I will take the data from time step 3 till 102, and use this particular thing for 103rd day data, forecasting 103rd day data, right? So in this way, this if and else loop will run. So else loop will run for my first iteration. I've calculated my y hat, or you can say I've calculated my 101th day data. I've put that particular 101 day data in my temp input list itself, right? And in my list output, that is the list that I'm using for showing the output, I'm also adding this y hat row, right? And now comes my second iteration. Now my length of temp input has increased. It is 101 now, because I also extended it by with the 100 first day data, right? So now my if loop will run. And from if loop, if you see at the first step itself, it will be taking the data from the second data point till 101th data point. That's why I'm using that. Okay, ignore the first data that is present inside my input list. Now again the same thing will happen. These 100 days data, last 100 days data starting from day 2 till day 101, that will be, first of all, it will be reshaped into a three-dimensional array. Then it will be it will be inputted inside my model.predict function. I will get a output, or I will get a output for 102nd day. I will extend, I will put this particular output inside my temperature in temporary input itself, and also in my temporary output also. So in this way, for 30 days my loop will go on running, and in this way I will be able to calculate the data for next forecast for next 30 days. This is one method for forecasting multiple steps in future. The other method is that initially when we were graphing, or when we were making the mapping of our data, we take 30 data frames itself, or what we can see here. For example, my application is forecasting into 30 days. So what I can do here, initially what I did, I just make T10 T1 to T100, right? And it was mapped with T101, right? And I just use multiple iteration for forecasting multiple steps into future. The other approach is, you can take T1 to T100 as one of the column of your array, T2 to T101, this way T30 to T129, and map this particular, this is now, this will be my X, and map this particular X with Y, that again will be my points, my array of T101, T102 till T130, right? In this particular thing, again my architecture of LSTM will change, because in my last layer, now instead of one dense layer, there will be 10 dense layers, and in the second last layer, again there will be 10 LSTM layers, and one of the these LSTM layers will be only directly directly mapped with the last layers. So instead of using sequential API in that particular thing, we will be using functional API of our TensorFlow, right? That is again another method for forecasting and steps into future. So now I have forecasted these 30 steps. I will be just inverse, I'm just taking the inverse transform, right? So this was my DDF. Now I'm just making some synthetic data dates for next 30 days by using pd.data range, right? So these are my next 30 days data values, and I'm just making a data frame of these particular forecasted values in df4. This is my df4. So this is basically my forecasted value of crude price for future, right? And now at last I will be plotting all the things together. So if you see, you will not be able to see the forecasted value because time scale is large, right? So let's just comment out the first two values, right? So this was my testing data, and this is my forecasted 30 days data, right? You can see it is kind of getting some of the trends from previous value. So this was the very basic code of using LSTM for univariate forecasting. Now coming to the drawbacks in this particular use case, we were talking about crude price forecasting, right? And we just used historical data of crude price, but this thing is not possible, right? Why? Because your crude price is not only dependable on historical data, but it also fluctuates with the geopolitics and many more factors. For example, Russia, there is a war between Russia and Ukraine. Your crude price kind of exploded. It reached $90. Your USA, if I show you the graph of our price, right? It kind of exploded here because of Russian and Ukraine war. Here, our USA explored that there is a shale gas present in their rocks, and they explored how to extract that and produce that. My oil price dropped from 130 barrels to around 30 to 25 to 30 barrels, right? So those things, those geopolitics things, so news and all those things, we haven't taken care in this particular model, right? That's why this is kind of a little bit not correct. It is just for learning purpose. You can refer it for learning purpose, but we cannot directly use this particular model for forecasting, right? So yeah, I guess that's all from my side. If you have any doubts, you can ask in the chat box. I hope you guys enjoyed the lecture and the things are cleared. Kind of covered a lot of things in 1 hour itself. But if you have doubts or something more, you can also reach out to my LinkedIn. And if you want to explore more of the projects, you can also go to my GitHub profile. Also, I have maintained different repositories for oil and gas industry also, and for different machine learning algorithms also. So you can also visit my GitHub also. And as already Mudit told about the my YouTube channel, so basically in my YouTube channel also we kind of upload all the things related to data science, machine learning, and deep learning. There are many playlists. You can also subscribe to our YouTube channel also. I guess Mudit will provide the links to all these things. And this particular notebook you can find out in my GitHub itself, in one of the repository, Energy DA from scratch. I have already uploaded this particular notebook before the session. Yeah,
Yeah.
Mudit.
Okay. Thanks a lot, Jayesh, for sharing this, and I think it was a very exhaustive and wholesome session where we talked about the end-to-end spectrum. One quick question that I have is basically when you were introducing the idea of crude crude
Crude
oil
oil forecasting.
price forecasting. Yes, sorry. You mentioned that it is helpful to have some domain understanding. Now, typically, data scientists have to anyway work across domains. Now, as somebody who's just getting started in this field, how do they navigate through these challenges? Because there are various fields there. So, how can one go about it?
I will give you one example here. For example, myself, I kind of switched out of oil and gas industry, right? So whenever I am working on any domain, example, for example, one of my project was related to some predictive maintenance of an instrument that was related to some aerospace domain. Let's assume that was related to some aerospace domain. So I needed to have a little bit research about that particular instrument, that okay, how does it work, what are the different data points that I am having in my data set, have the effect on working of that particular compressor. Because what I think is that data science or machine learning and all these things are just a tool. These are just a tool for solving a problem. You also need to have a little bit of a domain specific knowledge. If you are solving any domain problem, you need to have a little bit background of that domain. So having a mixture of both things, domain as well as data, that will result in a good problem solving approach.
Okay. Okay. And okay, one quick question. I mean, what exactly is predictive maintenance? You mentioned it several times. For those who are
Uh,
not from the
Basically,
industry, they
predictive maintenance is we are kind of getting to know when my certain equipment is going to fail. So, for
Hmm,
example, we are let's talk about a jet engine, right? So we have data for jet engine, historical data that okay, this jet engine fails in these type of scenarios. So if I know, for example, I know n time steps back, I know 1 to 3 days back that okay, maybe there is a chance that this jet engine is going to fail. So I can
hmm,
already take the predictive measures, right? Instead of waiting to one equipment to fail, we are just kind of forecasting its failure and taking
hmm,
all other measures so that we will be ready for that particular thing.
hmm,
That
hmm.
particular domain or thing is known as your predictive maintenance.
Okay, okay, fair enough. And I mean, typically in these scenarios, you talked about the limitations of the techniques that we saw right now. Now, on that front, I have a very quick question. A very recent session that we did was on using machine learning for streaming data, and that included the idea of using it for for predictive maintenance, basically for predicting when a machine will fail. Now, typically, as a data scientist, when do you decide when you go for batch processing versus streaming? Because it's just a generic question that I'm asking because it's something that one of the community members have put across.
Batch processing and streaming.
Yep.
right? That again completely depends on your use case and what type of I can say infrastructure we are having. For example, if there is a scenario that I want a result or I want a result, let's take an example from a computer vision point of view, right?
Hmm.
For example, let's assume that we are having some computer vision application inside an industry where I have
Hmm.
to predict whether one particular part is faulty or not, and
Hmm.
that part is going on a conveyor belt, right?
Right.
And one camera is situated above that conveyor belt, right? So there I have to tell them immediately. I have to tell whoever is operating there that whether this part is faulty or whether it is not faulty, because that will affect further operations also. Because if it is faulty, it need to be rejected from that conveyor belt, and if
Right.
it is not faulty, it need to go through, right? In that
Right.
scenario, we will be using our streaming data itself. And other, if we have some of the time gap between the you can say that is affecting our output, there we can use our batch inferencing.
Okay. Okay. Fair enough. Um. Okay. There's a question that Alan has asked. So first off, he says it's inspiring to see you start such a good educational initiative. May I know what inspired you to start Petroleum from scratch? Sorry, not this one.
Okay.
Yeah, I mean Petroleum from
Yep.
scratch. Yeah.
Yep. So, okay, the scenario was during the COVID times. We were at our homes itself, and there was, as I said, if you also see the graph of crude price during
Hmm.
COVID, crude prices kind of dropped to negative. It was around -$30, right? Let me show you the price itself here, if it is recorded. Yeah, this is the dip. It is not having the negative thing, but yeah, crude prices dropped. So oil and gas industry was kind of burning. It was kind of firing the peoples and all those things. And during that time, I was doing my master's from IIT ISM Dhanbad, right? I appeared for GATE. I was assuming that I will get a job in ONGC, but because of this particular thing, all the processes kind of stopped, and me and my colleagues that are running petroleum from scratch, we were not having any idea what to do, right? So we just started to learn, and our seniors that were present in oil and gas industry, they also didn't have any idea what to do and how they can guide us. So during that point, we started our data science industry, one and one of my colleague, Divanshu, we started our data science learning thing. And at that point, we decided that we need to discuss this particular thing, and we need to help the community or help our juniors already, or help the people that are in oil and gas industry or professionals that need to switch, or who need to know about these new techniques so that they can sustain in the industry. So that particular thing kind of inspired us for coming up with the petroleum from scratch initiative, so that
Mhm.
juniors as well as professionals both can take the benefit, so they need not to face the problems that we faced earlier.
That's a that's a great thing that at a moment where you were kind of seeing a dark, I'm not a dark, but yeah, slightly tricky pathway ahead, you decided to come forward and help at least others in the similar journey. So that was a very good thing. Kudos to you on that. I have a question that Idris has asked, if I'm pronouncing it correctly. So first off, he says great session. He has a query that is there some effective time series forecasting algo that is applicable to unsupervised learning approach.
Unsupervised learning approach again. How will unsupervised learning approach take the time series? I'm not able to answer this particular question. I haven't come across this type of thing that I'm applying a unsupervised learning approach in a time series problem.
Right. Okay.
There can be a scenario, okay, you can just apply KNN itself or some of these algorithms. There can be a scenario that there is your time series data. Again, I am taking example of predictive maintenance. There is your time series data, and we are just assuming that the two classes are there. One is your normal working class and other is your anomaly, right? So you can just view the that particular cluster, that whether it is kind of falling in one of these classes. But generally, unsupervised learning techniques we generally use when we have a lot of data and good type of data is present. I generally prefer supervised learning approach if I have the value of y itself. And in time series problems, forecasting problems, you will always have a value of y. There can never be a scenario that you need to forecast anything that you doesn't have target value.
Um, okay, I mean, just a small clarification that this has added to that. as in we don't have a target variable to train our data set.
And so then in that scenario, you just can use simple shallow learning techniques, simple shallow learning in supervised learning. There are nothing like this time series, specific time series unsupervised learning approaches.
Okay, okay. Um, Thanks for answering that. I think we are towards the end of our session. One thing that I want to quickly share is basically, let me just share my screen to give you a quick glimpse of it. Okay. So there are two things that, I mean, three things that I would quickly walk you through. First off is this session that we're looking at, the one with Jayesh. If you want to see more of these sessions, you can go to defi.tech/community initially, and then you will find this header. You can navigate through it and register for any of the sessions that you might be seeing upcoming or ongoing. Apart from that, this is the course that Jayesh and Divyanshu, basically the founders of Petroleum from scratch, they have created this course, and it's there on DeFi, 100% free. So kudos to Jayesh for creating this. This is one of the entire list of resources that he has created. He, as he might have mentioned earlier, there's a ton of other playlists that he has created. You will see them. On the internet. But yeah, if you want to register for this, even you can find it on the courses section. So go to defi.tech/courses. Again, as I'm talking about this, it's important for me to mention that none of it is commercial in nature. Just go on there, learn, and engage with the community out there. People are usually very helpful. So if you find stuck in any of the process or any part of your journey, you can ask, and people will be willing to come forward and help. The last thing that I want to point out is these two boot camps which are starting in less than 6 days as we're looking at it. Okay. So basically, if you're a beginner, you can go for the 5 weeks of data science boot camp, which will have week zero as a Python crash course, week where you can learn Python if you are an absolute beginner. And the second, the goal of this particular bootcamp will be to help you develop models and solve problems using data science. Okay, and this one is focused on deep learning, as the name goes by it. You will learn more of CNNs, GANs, etc. So then this would understandably require a foundational knowledge of data science and basic Python libraries, NumPy, Pandas, etc. So if you want to enroll for any of these, go ahead, head to the website and enroll now. And with this, we are towards the end of our session. There's a ton of gratitude from the community members saying that they love the session. And there's a quick question: is there any placement opportunity after the bootcamp session?
I guess this is for you.
Yeah. So I mean, okay. So Jayesh and I were having a very detailed conversation on this actually when we spoke a couple of weeks ago. So no, as of now, the way it works is so you'll find a lot of community members who are willing to help. Jayesh, in fact, is one of those. If you have got, if you're working hard and you're building your credentials and everything, you can, as I understand, you can try reaching out to him. He has pretty much shared about his GitHub, social profiles and all. So you'll find a lot of people in the community who are willing to help. So the goal of the bootcamp is to help you develop your skills and put you in touch with a global community of people who are willing to help. Jobs opportunities like placement opportunities per se, that is something that we don't dedicatedly offer on today's date. So if that answers the question, if you're coming on board, do come on board for the learning side of things. You would love it for sure. With this, we are towards the end of a session. Thanks a ton, Jayesh. I'm super happy that we had this session today, and I would thank everyone who, if joined on this weekend, learn. We'll see you very soon, and take care. Bye, everyone.
Take care. Bye, everyone. Happy learning.